Hi friends, my name is Brooke, and I want to thank you for joining me to practice some math. Today we are working on one-step equations. So this page shows us what one-step equations could look like if we saw them in images. One of our goals when we solve algebraic equations is to figure out what the letter or variable equals, and we also want to keep the equation balanced. So here's an example. Our example is showing us the equation y plus 5 equals 9. So in our image, we are seeing the letter y. It is a box that includes a mystery number of blocks. So it says that y plus 5 is the same weight as 9. So we're trying to figure out how many blocks are in this box. Right now, everything is balanced. We can see that the balance is going straight across, so our equation is balanced right now. We do want to figure out what y equals by itself. So the first thing we do is we take 5 blocks, we take those away from the left side. As you can see, that starts to make this side of the balance lighter, and our 9 blocks is heavier. So the equation is no longer balanced. We do need to balance the equation. So to balance the scale, we also have to take 5 blocks away from the right side to get it to balance again. Once you have balanced your equation and you have the variable by itself on one side, you will have your final answer. So we can see that y is equal to 4. So when we do our algebraic equations, we will always do the opposite operation to both sides. So this page lists the different operations and all of their opposites. You can see in our previous example, we started with the example y plus 5 equals 9, and we solved it by taking away 5 blocks from each side. So we do the same thing when we see these problems. We think about the operation that we see in the problem, and we do the opposite to both sides of the equal sign. Here is another algebraic equation that shows us a one-step addition equation. So here in our problem, we see y plus 14. We know that we want to do the opposite to both sides. The opposite of addition is subtraction, so we subtract 14 from both sides of the equal sign. Now, these cancel, so we have y all by itself on the left side, and then on the right side, 20 minus 14 gives us 6. So the final solution is y equals 6. We can always check our work by plugging your final answer back into our variable. So it's almost like you are evaluating expressions like you've practiced. If we put a 6 in for y, we can see that our answer does make the equation true. 6 plus 14 does equal 20. Here's an example of subtraction. We see a subtraction problem. Our problem is saying x minus 120, and we know that we want to do the opposite operation to both sides. Instead of subtraction, the opposite is addition, so we add 120 to both sides of the equal sign. That makes these cancel, so the x is by itself on the left, and then on the right, 80 plus 120 equals 200. We can check our work by plugging in your final answer in for the variable in your original problem. 200 minus 120 does equal 80, so that's how we know that the answer we got is correct. Here's an example of a problem where we see multiplication. We see a number right next to a letter. So that is telling me multiplication. I need to do the opposite operation to both sides. Instead of multiplying times 3 to cancel it out and get the variable by itself, I need to do the opposite of multiplication. The opposite of multiplication is division, so I should divide both sides by 3. So now I've got n all by itself on the left side, and then on the right side, 12 divided by 3 gives us 4. So again, I can double check my work by plugging in my solution in for n in my original equation. 3 times 4 does give us 12, so 4 is the correct solution. Here's one last example of division. We see something that looks like a fraction, so we know that that means division. The opposite of division is multiplication. So we're doing the opposite operation to both sides. Instead of dividing by 2, I am going to multiply times 2 on the left and on the right. That makes our 2's cancel so that we do get k by itself on the left. And then on the right, 16 times 2 gives us 32. So our final answer is 32. We can double check our work by plugging in our answer in for k. 32 divided by 2 does give us 16. So that's how we know that our answer is correct. Here are the practice problems. So there are 24 of them, and I will do all 24 in this video, but I really encourage you that as you start feeling more confident with this topic, that you try some out on your own. So looking at this problem, we always want to identify the variable and take a look at the operation that is being done to it. This time, our variable, b, is on the right side of the equation, and we see subtraction. So the opposite of subtraction is addition. We're going to do the opposite operation to both sides of the equal sign. We add 3 on this side, and we add 3 on this side. Now we've got b all by itself on the right side of the equation, and on the left side, negative 7 plus 3 gives us an answer of negative 4. They have different signs, so I subtracted the numbers. 7 minus 3 is 4, and our higher absolute value was negative, so we do get a negative 4. Here is number 2. Always find the variable and identify what operation is being done to it. I see addition, so I know that I should do the opposite operation to both sides. The opposite of addition is subtraction. So I'm going to subtract 8 from this side of the equation and subtract 8 from this side. So now I've got m all by itself on the left side. On the right side, negative 14 minus 8 gives us negative 22. So thinking through that part, negative 14 minus 8, you could have said keep change, change. You would have changed from you would have kept the negative 14, changed from a negative to a positive, and changed from a positive 8 to a negative 8. Then we see our addition problem. They have the same signs, so we add the numbers together. 14 plus 8 gives us 22. And our higher absolute value was negative, so our final answer was a negative 22. One thing to know, you always can plug in your final answer back into your variable, and it should work out. So let's just check our work on this one. Negative 22 plus 8 should equal negative 14. We will see if that's true. We have an addition problem, and they have different signs, so we subtract the numbers. 22 minus 8 does give us 14. And then we see that the higher absolute value is negative, so it is negative 14. So we do know that our final answer of negative 22 is correct. You do not have to check your work on every single problem, especially as you start feeling confident, but it's good to practice knowing how to check your work. Here is number 3. So we always pay attention to the operation that we see. And in number 3, we see addition. We always do the opposite operation to both sides of the equal sign. The opposite of addition is subtraction. So we subtract 13 from the left side, and we subtract 13 from the right side of the equal sign. That cancels the 13s, and so we will have x all by itself on the left side, and on the right side, 27 minus 13 gives us 14. Here is number 4. Always find your variable and pay attention to the operation that you see. So this time my variable's on the right side of the equal sign, and I see subtraction. We always want to do the opposite operation to both sides. The opposite of subtraction is addition, so I need to add 32 to both sides of the equation. Now I've got y all by itself on the right side, and then on the left side, 12 plus 32 gives us a final answer of 44. Here is number 5. On this problem, we see multiplication. We found our x, and we see that we've got a 4 right next to it, and we know that anytime we have a number right next to a variable, it means multiplication. Since we see multiplication in this problem, we need to do the opposite. The opposite of multiplication is division. We divide both sides by 4. Now we've got x all by itself on the left side, and on the right side, 12 divided by 4 gives us a final answer of 3. Here is number 6. We always look for our variable. We see our variable on the right side this time, and we see multiplication again. We see the 15 right next to the x. So when we see multiplication, we should do the opposite. The opposite of multiplication is division. We divide both sides by 15. Now we've got x all by itself on the right side, and on the left side, 45 divided by 15 is 3. Here is number 7. Always find your variable and pay attention to the sign that you see. We see division, so we need to do the opposite to both sides. The opposite of division is multiplication. So we're going to multiply times 3 on both sides of the equal sign. That makes the 3's cancel, and we will have the x all by itself on the right side. And then on the left side, 19 times 3 gives us 57. Here is number 8. We always focus on our variable and pay attention to the operation that we see in the problem. We see division, so we need to do the opposite to both sides of the equal sign. The opposite of division is multiplication. I'm going to multiply times 9 on the left and times 9 on the right. So now I've got x all by itself on the left side, and then on the right side, 8 times 9 gives us an answer of 72. Here is number 9. In number 9, we see subtraction, so we need to do the opposite operation to both sides. We need to add 18 to both sides of the equal sign. Now we've got n all by itself on the left side. That canceled the 18s, and on the right side, I need to focus on negative 21 plus 18. So I notice that these have different signs, so we should subtract the numbers. 21 minus 18 gives us 3, And then our higher absolute value was negative, so we do need a negative sign. Our final answer for number 9 is -3. Here is number 10. Always find your variable and pay attention to the sign that you see. We see subtraction, so we need to do the opposite of subtraction. And the opposite of subtraction is addition. We need to do the opposite operation to both sides of the equal sign. Now we've got R all by itself on the left, and on the right we've got 29 plus 12. That gives us a final answer of 41. Here is number 11. Always find your variable and pay attention to what's being done around it. Our variable this time is all the way on the right side of our equal sign, but I see addition. So this is just like saying v plus 8. That's the same as saying 8 plus v. But since I see addition, I need to do the opposite operation to both sides of the equal sign. The opposite of addition is subtraction, so I'm going to subtract 8 from both sides of the equal sign. Now I've got v all by itself on the right side, and on the left side, I've got -10 minus 8. So let's think through this problem. -10 minus 8. We see a subtraction problem, so we can say keep, change, change. We keep the -10, change from a minus to a plus, and change from a +8 to a -8. Now we see an addition problem where they have the same signs. So we say same signs add. 10 plus 8 gives us 18. And since they were both negative, we do get a negative answer. It's a good idea to go to your higher absolute value when you're doing addition. So go to your higher absolute value, and it was negative, so we do get a -18. Here is number 12. Always find your variable, and this time we see addition, so we want to do the opposite to both sides of the equal sign. The opposite of addition is subtraction. We can subtract 19 from both sides. Now we've got m all by itself on the right side of the equal sign, and then on the left side, 31 minus 19 gives us an answer of 12. Here's our next page. So this one looks tricky, but we're always going to find our variable and pay attention to the signs around it. This is like saying plus a negative. So we really want to cancel out a -19. When we have problems that say plus a negative, it's really like subtraction. So the opposite of subtraction and canceling out a -19 is addition. We are going to add 19 to both sides. So now we've got m all by itself on the left side. And then on the right side, we have -21 plus 19. Those have different signs, so we subtract the numbers. 21 minus 19 gives us 2. And then the higher absolute value was negative, so we do get a -2. So on this one, since the signs were tricky, I am going to double check my work. I'm going to plug in my -2 in for m. -19 plus -2. These have the same signs, so we add the numbers together. 19 plus 2 gives us 21. And our higher absolute value was negative, so final answer is negative. So we can see that our answer is correct. Here is number 14. This time we see subtraction, so we need to do the opposite to both sides. The opposite of subtraction is addition, so I'm going to add 11 to both sides of the equal sign. Now I've got n all by itself on the left side. The 11's canceled, so on the right side, I'm just doing 2 plus 11 to get a final answer of 13. Here is number 15. Always find your variable and pay attention to the sign that you see in the problem. We see subtraction, so we should do the opposite to both sides. The opposite is addition, so we are adding 7 to both sides of the equal sign. That cancels the 7's, so we do have x all by itself on the left side, and then on the right side, these have different signs, so we subtract the numbers. 19 minus 7 is 12, and our higher absolute value is negative, so our final answer is negative. Here is number 16. We find our variable, and this time it's on the right side of the equal sign. We see subtraction, so we should do the opposite to both sides, and the opposite of subtraction is addition. We're going to add 14 to both sides of the equal sign. So now I've got m all by itself on the right side of the equal sign, and on the left side, negative 2 plus 14 is what we need to do. We see that they have different signs, so we should subtract the numbers. 14 minus 2 gives us 12, and our higher absolute value was positive, so we do get a positive 12. Let's go ahead and double check our work on this one as well. So I'm going to plug in 12 in for m. So if you are ever unsure, especially on problems that have some tricky signs, you should go ahead and double check your work. So I'm plugging in 12 for m. So I need to double check that 12 minus 14 does give us negative 2. So you could say keep change, change. We keep the 12, change from a minus to a plus, and change from a positive 14 to a negative 14. Now we see an addition problem that has different signs, so we should subtract the numbers. 14 minus 12 gives us 2, and our higher absolute value was negative, so we should get a negative 2. So we can see that our solution, 12, was correct because 12 minus 14 does give us negative 2. Here is number 17. Next to our variable, we see addition, so we need to do the opposite operation to both sides. The opposite of addition is subtraction, so we are subtracting 14 from both sides of the equal sign. Now we will have x all by itself on the left because the 14's cancel, and then on the right, we've got 1 minus 14, which gives us a negative 13. Here is number 18. This time I see something that looks like a fraction, so I know that this is really division. The opposite of division is multiplication. So I'm going to multiply both sides times 5. That will cancel out the 5's in the problem, and it will leave n all by itself on the left. On the right side, we've got 12 times 5, which gives us a final answer of 60. Here is number 19. This one can be tricky because we do see a negative sign, and sometimes we think about subtraction when we see problems that look like this. But this problem is really showing us multiplication because we see an integer right next to a variable. So this is really telling us negative 16 times x is equal to negative 48. So since this is multiplication, we need to do the opposite to both sides, which is division. We are dividing both sides by negative 16. So that does cancel out the negative 16s on the right side. One thing to notice is that I did not change the sign of the integer. We are only doing the opposite operations, not the opposite signs. We still need to divide by a negative 16. So looking at the left side, negative 48 divided by negative 16. That gives us 3, and it is going to stay positive. Whenever you're dividing, if they have the same signs, we get a positive answer. So x is equal to 3. Here is number 20. We see a number right next to a variable, so we remember that that means multiplication. The opposite of multiplication is division. So we are going to divide both sides by 10. That cancels the 10s, so I have r all by itself on the right side, and on the left side, 190 divided by 10 gives us a final answer of 19. Here is number 21. So we always go to the side that has our variable. This time it's on the right side. And I see subtraction. So we do the opposite operation to both sides. The opposite of subtraction is addition. So I'm going to add 17 to both sides of the equal sign. Now I've got a all by itself on the right side, and on the left side, we've got different signs, so we subtract the numbers. 17 minus 3 gives us 14, and our higher absolute value was positive, so it should end up being a positive 14. Here is number 22. Always find your variable and pay attention to the sign that you see. We see subtraction, and the opposite of subtraction is addition. We will add 9 to both sides of the equal sign. Now we have n all by itself on the right side, and on the left side, 8 plus 9 gives us a final answer of 17. Here is number 23. We're starting to see some big numbers. We see a negative number right next to a variable. So this is really telling me to do multiplication. This says negative 18 times a gives us 900. So the opposite of multiplication is division. We're going to divide both sides by negative 18. So if you remember, we keep saying we do the opposite operation to both sides, not the opposite sign. Keep the sign the same, but change the operation. So we are dividing both sides by negative 18. We will still have a by itself on the right side of the equation, and then on the left side, 900 divided by 18 gives us 50. And since we're dividing and they have different signs, we do get a negative 50. Here is number 24. We see multiplication, so we need to do the opposite operation to both sides. The opposite of multiplication is division. We divide both sides by 3. Now we've got x all by itself on the right side, and then on the left side, 12 divided by 3 gives us a final answer of 4. So I hope this video helped you out. You are always more than welcome to ask me any questions you have, or you can ask your instructor. Thanks again for joining me to practice some math, and have a great day.